Hey guys, today we're going to do logarithmic functions as inverses. So you will be able to write and evaluate logarithmic expressions, and you will be able to graph logarithmic functions. So our essential understanding, the exponential function y is equal to b to the x power is 1 to 1. So its inverse is x is equal to b to the y power. Because remember when we found our inverse, we switched x and y. To express this as y as a function of x for the inverse, we are going to write y is equal to the log base b of x. So a logarithm base b of a positive number x satisfies the following definition. For b greater than 0 and not equal to 1, log base b of x is equal to y if and only if b to the y power is equal to x. So you can read this as log base b of x, or the logarithm is an exponent to which b must be raised to get x. So I have found it easier to change the x and the y to an a and an e, so that we have log base b of a is equal to e, where we have b, a, and e being our base, our answer, and our exponent. So we can say log is b, b-a-e, and then our exponential equation is abe. Answer is equal to our base raised to the exponent. This is just an easy way for you to remember b and abe. So problem 1, writing exponential equations in logarithmic form. So what is the logarithmic form of each equation? Remember abe. We're going to remember abe. And we are going to remember log is b. So we have our answer is equal to our base raised to our exponent. So that means writing it in logarithmic form, our log base 10 of our answer 100 is equal to 2. So what is that saying? What power do you need to raise 10 to get 100? And the answer, or the exponent, would be 2. Evaluating a logarithm, what is the value of log base 8 of 32? Remember, log is b. And we know abe. So we have our base is 8, our answer is 32. So we have 32 is our answer is equal to our base 8 raised to an exponent. So now we're going to rewrite 8 and 32 so that is we have a common base. 38 is 2 to the third power raised to the e power is equal to 2 to the fifth power, because 2 to the fifth power is 32. So we have 2 to the fifth power is equal to 2 to the 3e power, because when we have a power to a power, we multiply them. Since we have the same base, we can take our exponents and set them equal to each other. So 5 has to be equal to 2e. Solve for e, making our exponent equal to 5 over 2. 5 over 3, I'm sorry. This should be 3e. Because it was 3e here. So e would be equal to 5 over 3. A common logarithm is a logarithm with base 10. So you can write a common logarithm of log base 10 of x simply as log of x. So when we don't have a base, we say that the base is 10. a logarithmic function is the inverse of an exponential function. So the graph shows y is equal to 10 to the x power, and its inverse, y is equal to log of x. Note that 0, 1, and 1, 10 are on the graph of y is equal to 10 to the x power. And we have 1, 0, and 10, 1 are on our graph for y is equal to the log of x. So if we remember, our inverses is the reflection of our function over the line y is equal to x. So we switched our x and y values to get our inverse. So graphing a logarithmic function, we're going to graph our exponential function, then reflect our values. So first we're going to graph y is equal to 3x. We know our asymptote. We're going to plug in 0. We get 0, 1. That's 3 to the 0 power. 2. -1, 1/3, -2, 1/9. Then we have 1/3, and we have 2/9. Now I'm going to take these and reflect them over our line y equals x, so that we're going to have, this is our new x column, that's our new y column. So 3, 0, 1/3, -1, 1/9, -2. I'm sorry, this is 0, 1. Because when I plug in 0 into my original equation, I get 1, and I get 3, 1, and I get 9, 2. So those are my inverses. And our domain is x is going to be greater than 0 because we have our asymptote at x equals 0, and our range is all real numbers. So our domain, x needs to be greater than 0 because our asymptote here is at x equals 0, and our range, y, all real numbers. That's all.